see something, say something.
Yeah, exactly.
All right. So I want to go ahead and do the first two multiple choice ones, and then I want to give you a little bit of time to try the back side. And I at least want to get to the point. Oh, almost.
Close.
I at least want to get to the point where you can set up the integral for the differential equation. If you can get that far, that's really as far as I care for you to go. So number 3, we've got that expression for velocity and time. We got to integrate the acceleration in order to get that velocity. So acceleration, I'm looking at the answer key now. I'm not looking at the question. What does the question actually give you?
The acceleration equals meters per second.
Equals how many?
2 meters per second.
Second.
T.
Or
Cubed?
Yeah. It says cube T.
it's cube T. Yeah.
Let me take a look.
I'm not even kidding.
I never noticed that it said that, so
I'm
I
not
did
even
this all
kidding.
wrong.
I was confused. I was confused.
Oh, that's
why is not such thing?
I did not notice that until just now, so I did all
cube or
this wrong.
square?
It should be squared.
Yeah. I was like, where did you? That's not how
Right.
I solved it.
So this just means your acceleration is changing with respect to time. As your time changes, your acceleration will be a little bit different.
And
So-
T is greater than or equal to 0.
Yep. So we got to take the integral of acceleration because that's going to get us velocity. And once we have velocity, we can take that integral to get position. Yes?
I need the sheet.
Oh, sure. Check the second tray down in the back. Should be an extra one, I think.
I really hope I didn't do the extreme hard way.
I didn't check the whole thing.
Yep, I did the extreme hard way. No reason.
So, what's the integral of 2t?
That would be
It would be
T.
no
T
plus
squared.
constant.
That would be 1/2.
T squared plus something.
Plus constant. And because we're now a velocity, what's that constant going to be, you think?
Velocity.
VO, yep. So that's our first integral right there.
Wait a second. But wait, yes. Okay.
So that's our velocity with respect to time. Now I need to use this in order to get our position with respect to time. So position is equal to the integral of velocity. So all we got to do is integrate the velocity.
Is that 1/3 T plus VO plus
Yep.
VOT.
So plus 1 is 3. Inverse is 1/3. So 1/3 t cubed plus vt
Wait, hold on.
plus x original.
Where did you get the X?
You have to add the constant.
Yep.
Because when you take the derivative, you don't know if it was there or not. You know, I'll stop talking.
No, you're exactly right.
She's right, but I can't understand.
And in the same way that when we put a v in for our constant here, because we're solving for velocity, so our constant is just whatever velocity we began at.
Yeah.
Here, when we added a constant, we added the original position, because we're solving for position, so our constant is wherever our original position is.
Wait a second.
I did this
Something
so
is
much
wrong. Shouldn't it be 1/2 t squared?
No.
Why? How do
Because
you
you add-
integrate?
The 2 goes away because the 1/2 would come down.
So you're taking the integral out of the
Ah,
integral,
ha!
basically. Gets it. So you take the integral
Brain
out of
time.
the integral, basically.
Yeah.
Okay, got it.
The brain from Arthur?
So,
Yes, sir.
you get this far.
Is that Corbin Blue from Jump In?
Yes, sir. Oh wait, there you go.
No, you may not. Yes, you may.
So now, it says specifically in this problem that our original velocity is 0.
So it's VOT.
So this is 0 here.
Wait. Initially at rest. Okay.
Yeah, it's originally at rest, so that velocity goes away. This constant is something we can't exactly solve for. We're left with this right here. So if we're integrating that over 0 to 3 seconds, it says, then you're just going to plug in 3 for the time. 3 cubed is that 27?
Yes.
27 divided by 3 is 9. And that's what your answer should be.
Do we have to do 9 minus 1 over 3?
Oh wait, I did it right then.
9 minus what?
1 over 3. I think 1 cube.
Wait, how did that work?
Why don't we subtract the bottom? Like subtract 0.
Oh, well, you can. So it'll be 1/3 times 3 squared minus 1/3 times 0. So yeah, you're right.
I'm using this because I was too lazy to get fast from you.
I missed it.
There you go.
I'll be right
Thank
back.
you.
It's watermelon. It's really good.
Oh, that's a watermelon?
Yeah.
I gotta have that one. Here, you can throw this one again later, too.
No, it's already thrown. It's gonna
Oh,
be
it
a
is?
different one every 5 minutes.
Oh, cool. Questions on the integral?
Wait.
Yeah, the thing is now integrals.
Okay,
How to
okay.
set up
So you have 1, 2, 3, 4, 5. Bottom line, yeah. The left half of it. What is that?
So this is where we're taking the integral of this.
Okay.
Because position is equal to the integral of velocity.
Because, okay. Yes.
Yeah.
Alright, I got it.
Okay.
Because I would just show less steps. Okay.
Number 24 then. We've got a function 6t squared plus 4. Is that right? That's what they give you?
No, wait.
No.
24?
What
No,
do
that's
they?
what- here.
What's the starting expression?
I actually did this one.
2t plus 4t plus 6.25.
6.25.
Yeah.
All right. So this is where you begin,
Got the answer right.
and you want to end with acceleration. You got to take your position and take 2 derivatives. So the first derivative of this.
6t squared plus 4.
Yep.
Yeah.
What's the second derivative?
12.
12t.
And what do we plug in for t? 1.5 times 12 is
18.
Yep.
Okay, that's
So much easier with the guys plugging them in first.
Yeah, derivatives are easier for sure.
Wait, I forgot how to do derivatives.
I didn't realize we were finding derivatives, and I think I did.
Real quick here.
We have a very serious
So
one.
here's how this works.
Never did you draw that on the board.
Seemed like everybody got the first part. You've got normal force up, gravity down, applied force this way, and kV, the drag force, going left. So if you're going to go ahead and do part B then, you have to solve and set it up as a differential equation. So because the acceleration is horizontal, you're just looking at the horizontal forces. So force equals mass times acceleration. Applied force right minus drag force left equals ma. Another way to write A is derivative of velocity with respect to time. And that's letter B. That's starting that differential equation. Questions on letter B?
That's how you get
That, why are you saying that?
No, we
Because
might
I still haven't watched the video of the class, and now it makes sense why that works.
I will be passing this answer key out. So if you get lost, that's okay. I'll give this to you. So letter C, we're solving for what's it called? Terminal velocity. And so terminal velocity is basically when you're not speeding up or slowing down anymore. So what that means is that we have no more acceleration. So acceleration, which is dv by dt, goes to 0. In other words, applied force minus drag force is equal to nothing. So to solve for that velocity, you just isolate the v.
Yes, you did. Good job.
Questions on letter C? Why is what? You'll get this in a handout. So then, I'm going to go to a
I
different
could
picture.
get like 60% of my
Is-
test. Oh, fuck.
Hey.
No.
Set the bar a little
We have
high.
tests.
Let's aim for 62%.
All right.
What's that?
Do 61.5%.
Let's do it.
So, the next part of this is asking you to use the differential equation to derive the equation for speed of the box as a function of time. And that's where we get into the stuff that we've been doing in class more. And that's what this part is right here.
Why can't you plug in 0 for V?
Which
Right
one?
here. Because we're not at terminal velocity
No,
anymore.
on the other side. It's like, because assume V equals 0 and T equals 0, so can't KV equal 0? So just before supply equals mass times the derivative?
Why do you think you can set velocity equal to 0?
Because assume that
It
V
says
equals 0 and
says
time
on the
equals
list
0.
0.
Assume that velocity is 0 when time is 0. That's true.
Oh, at, haha.
But, yeah.
I can't read.
So,
So it just means that you're starting from a stopped position.
yeah. So, here's our expression, the one that you found in letter A, I think it was, letter B. So, same expression that we used for the last part. In order to get anywhere with this, we have to get the dv and the dt out of here so that they're not, so that the dt is not in the denominator anymore. It's got to be up here. So, the main thing you have to realize when we're doing what they call separation of variables is if you have the same letters, they got to be together. So we want the dv and the kv on the same side. So we're going to take this dv, leave it here. We're going to divide both sides by this, which is why we have 1 over fa minus kv dv. You're chucking this down here, you have to divide both sides by it. That's why it's down there. So because that's all over here, we got to put the m and the dt on the other side. So that means we multiply both sides by dt, divide both sides by m, and that's why we have 1 over m dt. What is that one?
Milky Way.
Milky. Oh, I love Milky Way. Thank you.
Why do you have Milky Way?
It's life. It's Sarah.
So, questions on this, going from here to here.
It makes math sense now.
And then going from here to here, you're just putting in the sign for integral.
Why do we integrate?
Because for the next part, you have to
You don't have
to derive the equation for the speed of v. So you got to use that to solve for v as a function of time. But I could care less if you could solve that. The reason is, when I pass this out, you'll see that this question is worth 4, 5, 6, 7, 8, 9, 10, 11, 12. This question is worth 12 points. Up to this point is 10 of those 12 points. Everything else, which looks like crazy handwriting, all this is 2 points. This is like nothing. If it were me, I would skip this whole darn thing down here. If you get 10 out of 12 points on a free response question on a physics test,
That's a 5.
you're good as gold. All right? So, the important part of all of this is I really just want you to be able to get to this point. If you can do that, I'm very, very happy with you.
We just have to do math. Wait, what about part E?
Part E, I'm going to hand out the answer key, and then I can talk you through it.
Wait, are we still being recorded?
Yeah, I'll let it go until the end.
Is the bomb.com still a thing?
It's not right now.
It can be!
Only in your world.
Mr. Lovelace, do you say bomb.com? Or have you ever heard that? Mr. Huckley, have you ever heard bomb.com?
No.
You
should be saying bomb out loud. Or on camera.
I'll search it. I'll Google it right now.
No.
That's
It's
the
not
type
a
of thing
site,
you wanna
it's
search
like
for
a
in school.
saying.
What?
It's not a site, it's just a saying.
Okay.
It's a saying. Yeah.
It's like, those shoes are the bomb.
Yes! You heard it? Haha!
Yes, I have to.
How many years?
So if you really want to do this integral, I did not just give you the answer key. I also gave you my work on there to actually make sense of how they did that integral. It's a lot of u substitution. And once you do all that u substitution, you'll eventually finally end up down here. But again, if you look at the point distribution, all this crazy math is worth 2 of 12 points.
Hey, I got 4 points.
Everything else before that, where you're basically doing stuff that's actually doable, that's 10 of the 12.
You could get like a solid 2 just by
This
knowing your
is
force
1.4
diagram.
Yeah. Well, that's 4 points. That's a third of the question. A third of the question is just putting the 4 arrows on it. So even
Do they have
though
to be equal?
no, because it doesn't say if it's picking up speed or slowing down. So even though this is hard, and even though I'm kind of focusing on the hard stuff in this class, that's just so that you get, the hardest part of it. If you're still good with a lot of the regular physics stuff, that's what's really important.
I'm not good with any.
And that's the last thing on